So I ask you to take a look at this check your understanding question where you're asked to determine the formal charges on each of the atom, and then of course write down the formal charges where appropriate. As a bit of a hint, all the carbons in these structures are going to have no formal charges, so you're probably going to want to look elsewhere. Also note that I called these Lewis structures. Technically, they're somewhat of a fusion between bond line drawings and Lewis structures. So note that I'm not being so careful here in that I haven't actually shown a full Lewis structure. But we're focusing on formal charges, and so please stop the video and write in the formal charges. Okay, so in terms of formal charges, normally it's not necessary to write in if there's a zero formal charge. So technically I could write a 0 next to that nitrogen, but usually we don't bother. So this particular molecule that we start with here has no formal charges. However, this particular nitrogen has a negative formal charge. Just as a quick calculation, a neutral nitrogen has 5 valence electrons. And we can see that if we consider how many valence electrons this nitrogen owns, it is 6. It owns 4 electrons that are associated with lone pairs, and then half of 4 electrons that are bonding pairs, so that's a total of 6 electrons, so a negative formal charge. Coming over to the molecule on the right, 0 formal charges throughout. The alcohol molecule in the bottom left-hand corner, 0 formal charges throughout. Note that there is, of course, a bond between the oxygen and the hydrogen, although often we'll just write OH. That said, this next structure has a positive formal charge. So again, oxygen neutral would have 6 valence electrons. Oxygen in this case owns the lone pair and then half of the 6 bonding pairs. So that's a total of 5 electrons. So that would be +1. And then finally, the oxygen here has a negative formal charge. Again, oxygen neutral 6. And then how many electrons does this particular oxygen own? Well, it's in fact 7. It owns the electrons in the 3 lone pairs, so that's a total of 6 electrons, plus half of a bonding pair, so that's a total of 7 electrons, a negative formal charge. Now before we go on, there's something that might be useful to do right now. You can always calculate what the formal charge is, but it might be helpful just to remind yourself that when you're looking at the typical atoms that exist in organic molecules, and of course this would be carbon, nitrogen, and oxygen. If carbon is making 4 bonds, then carbon will be neutral in that particular molecule. If nitrogen is making 3 bonds, then that nitrogen will be neutral. If oxygen is making 2 bonds, then that oxygen will be neutral. So I'm looking at my 2 bottom examples here where I had formal charges, and in the middle example, the oxygen is actually making 3 bonds. And so that alerted me that there'd be a formal charge, and then I can calculate it. The oxygen in the right-hand side molecule is only making 1 bond. So that alerts me, oh yeah, there's going to be a formal charge. Whereas the oxygen in the left-hand structure at the bottom is actually making 2 bonds. There'll be no formal charges. Note that in this structure right here, the nitrogen is only making 2 bonds, not 3 bonds. Again, that alerts me that there will be a formal charge. So I think that if you can keep this in mind, it will allow your brain to pick out when to expect to see formal charges. Now, I ask you at this stage to look at exercise number 1. I'm only going to look at the first row here. The answers to the other rows you can find on your Moodle page. But I want to do the first row with you because I think it's pretty important. I ask you to stop the video and consider trying to draw a structure that involves carbon. Essentially, it's just a modification of our methane molecule that has a +1 formal charge. And then to draw carbon, an extension of our methane molecule that has a negative charge. What might be helpful is I'm going to start off here and I'll write N. Of course, this will be 4, 4, and 4, and then owns. So of course this would be 4 if it's going to be neutral, no formal charge. This will be 5 if we're going to have a negative formal charge. So the carbon has to own 5 valence electrons. And the carbon in the example of having a positive charge only owns 3 valence electrons. So consider how this can happen. So let's start with our carbocation, the carbon with a positive charge. So carbon, if it's making 4 bonds, will be neutral. The carbon with a positive charge is not making 4 bonds, and in fact it's making 3 bonds. And so it will own half of those 6 electrons, therefore 3 electrons. Therefore there'll be a positive formal charge. This is the carbocation. Note that the carbon actually doesn't have an octet. So this is actually not very stable, but we'll often see this, especially as an intermediate in a reaction mechanism. And so in a sense it is a legitimate Lewis structure. Now how can carbon have a negative charge? So I'll draw in these 3 hydrogens, and you say, well, how can carbon actually own 5 electrons? Well, one possibility would be this, and I hope actually you didn't draw this, because of course carbon is breaking the octet rule by having too many electrons. Over here on the left hand side, this is the only time we will see carbon break the octet rule, is having too few electrons. Carbon will never break the octet rule, nor will nitrogen or oxygen never break the octet rule by having too many electrons. So what I just drew is impossible. So how can we have carbon have a negative charge? Well, it's a lone pair of electrons here. This is a carb anion. Of course, carbon here would own 5 valence electrons. So this is our carb anion. These examples, I think, are relatively important as you will encounter them throughout the course. Now this little video clip, I think, helps summarize some of the things that we were just talking about. I'm going to talk you through it, and I will also guide you later where you can find such kinds of video clips in our Moodle page so you can review these yourself. So you can see that we're starting off with this thing, carbocation, where there's a positive charge on the right-hand side carbon. What's nice about this little video clip is it shows us what's going on around each of the atoms in terms of how do they end up with those particular formal charges. So let's see here. So first of all, the carbon on the left-hand side. So instead of using the dashed lines to represent the bond, it's using dots, and it's showing that we have, in terms of neutral carbon, 4 electrons. Now note what they say here is in the free atom, but that's equivalent to our neutral carbon. And then in the bonded atom, well, that's equivalent to how many electrons the carbon owns. And so it makes sense that that carbon would be neutral. So I'm going to move the video clip along a little bit. And now we look at the carbocation. So in this case, we can see that, of course, carbon, neutral, would have 4, whereas the carbocation only owns 3 electrons. So of course it will have a positive formal charge. In this next example, we have the carb anion. So again, neutral carbon, 4 valence electrons. You can see with the carb anion, the oxygen owns 5 valence electrons, therefore the negative charge. This is our example of the carboxylate. You'll see this often. The oxygen at the top is neutral. Neutral oxygen has 6 valence electrons. This oxygen owns 6 electrons, therefore the formal charge is 0. The oxygen, however, at the bottom owns 7 valence electrons, therefore it has a negative formal charge. Lastly, we look at this example of the nitrogen. Nitrogen, neutral, has 5 valence electrons. In this particular case, it only owns 4 electrons, therefore it has a positive formal charge.